Hello, everybody. All right, we're getting near the end of this thing. We got two modules left. This one, 15, and the next one, 16. In these two modules, we're going to cover something called process safety management. It's technically called process safety management of highly hazardous chemicals. It's 29 CFR 1910.119, and it is an extremely important standard. You can see it's highly hazardous chemicals, and there's a whole bunch of highly hazardous chemicals out there. My first introduction to process safety management, when I first started at OK Foods, I was there. I didn't know anything about process safety management, never worked in a company that had highly hazardous chemicals. We got a notice from the EPA that they were going to audit our PSM program in the Heavener facility. We didn't really have a PSM program, although we should have. So the people at Heavener knew a consultant, Craig Richter, called him. He came in. We went in the conference room for 10, 12 hours a day for like 2 weeks because we had some notice. And we basically slapped together a process safety management program to get us through the audit. And actually, it worked pretty well. We got through the audit with a few bumps, but not too bad. But that got us started. We realized that maybe we better get our butts in gear and do this process safety management thing. So, again, I didn't know much about it. So what I decided to do was I put together a corporate team, a process safety management corporate committee, to write a manual for our company. So we did that, and we got together 2 hours on a Thursday, 2 o'clock on Thursdays, for 2 hours, and there was people came. Some most not everybody came to every meeting, but we had like 10 of us on the group, and we went through this step by step. Now, Craig Richter, the consultant, he gave us the kind of an outline on some stuff. So he gave us a little bit of stuff to help him to help. And we put together a process safety management, corporate process safety management, which all the plants that followed under it because of our anhydrous ammonia followed. And we met for 2 hours a week for probably a year. And then we stepped it down to 1 hour a week, and then we actually at the end we were just down to 1 hour a month that we met. So there wasn't that much to do then, just kind of follow up on things, or if we had audits and stuff like that. And then we had EPA audits at Plant 2 in Fort Smith, and also at Mulder later on, and we did pretty good on those. So process safety management of highly hazardous chemicals is a very important standard. And even if the company you're with doesn't have highly hazardous chemicals, there's a lot of stuff in here that can help, because it's basically a preventive maintenance program. It's part of it, but it's a whole program of things. We'll cover them here, and that's why it's important. And it's basically a huge risk management standard, really, because the risk being identified in general is highly hazardous chemicals, and highly hazardous chemicals are a huge risk. Because they're a big risk to your people, they're a big risk to the public even, and the environment. So there's a lot of risk with highly hazardous chemicals, and that's why that this thing is so useful, even if you don't have highly hazardous chemicals. All right, this is broken down into a bunch of different sections, and this is section A, applicant. There by small letter A, like OSHA does it. We're going to cover them all, but we're going to cover in this module, we're going to cover all but two of them that require audits, and we're going to cover them in the next module because they're a little bit bigger. So we're going to cover a lot of it in here, and please pay attention because this is important stuff in your career. Again, it's process safety management of highly hazardous chemicals is 29 CFR 1910.119. And A is application. Like most standards, they start off with something pretty simple. This section applies to the following: a process which involves a chemical at or above the specified threshold quantities listed in Appendix A to this section. Okay, right off the bat, they're throwing you right back into the section. Appendix A is pretty long, and it has a whole bunch of chemicals listed in there and has their threshold quantities. For anhydrous ammonia, it's 10,000 pounds. So if you have 5,000 pounds of anhydrous ammonia, you don't have to be under this standard. But if you have more than 10,000 pounds, which we did at the three facilities, you do. So that's the section you want to look at to find out if you're even in this standard. You're covered by this standard. So we're going to look at a part of it. And this is just a very small part of it. This is what has the chemical name, the CAS number, and the TQ, which is threshold quantity. And you can see about the 6th or 7th line down, ammonia anhydrous. Anhydrous just means without water. I mean, just pure ammonia. Ammonia is usually watered down. It likes water. It mixes with water pretty well. And so anhydrous ammonia means without any water in it. And the TQ, the threshold quantity, is 10,000 pounds. So this appendix, most of the appendices in OSHA, they tell you if they're mandatory or not. This one's mandatory, that's for sure. And that's just the page with the A's, the A's in it. So that's a pretty big standard. So you need to make sure if you're, of course, you have to have a chemical inventory under hazard communication, and so you need to take that chemical inventory and look at the Appendix A of this to make sure none of them are qualified under process safety management. So a process which involves Category 1 flammable gas, as defined in 1910-1200 C, or a flammable liquid with a flash point below 100 degrees on site in one location in a quantity of 10,000 pounds or more. So this is saying, in addition to that, here's some other thing. Category 1 flammable gas, and in 1910-1200, and that's your hazardous materials thing. So that's another standard. Whoops, get too fast here. All right, back up. Hydrocarbon fuels used solely for workplace consumption as a fuel. For example, propane used for comfort heating, gasoline for vehicle refueling. If such fuels are not part of a process containing another highly hazardous chemical covered by this standard. Flammable liquids with a flash point below 100 degrees Fahrenheit, stored in atmospheric tanks or transferred, which are kept below their normal boiling point without benefit of chilling or refrigeration. This section does not apply to retail facilities. So it's a retail store, doesn't apply. Oil or gas well drilling or servicing operations. Why? Again, because they've got their own rules. Normally unoccupied remote facilities. Normally unoccupied. In other words, somebody goes there once in a while to check on something, but normally there's nobody there. Element A tells us who comes under the process safety management laws, and in some cases who doesn't. So that's what we talked about here. Most poultry process or other companies with large refrigeration needs use anhydrous ammonia as a refrigerant, and that's what puts them under the PSM standard. These are just my notes here. So that was A, just kind of application, who it applies to. Now, B is definitions, and most OSHA standards that are big as this one have definitions. We're going to look at them. Catastrophic release means a major uncontrolled emission, fire, or explosion involving one or more highly hazardous chemicals that present a serious danger to employees in the workplace. Well, if you have an uncontrolled emission, fire, explosion involving a highly hazardous chemical, it's probably going to present a serious danger to employees in the workplace. Now, remember, they're the same to employees because this is OSHA. OSHA doesn't have any jurisdiction over people, the public, just the employees. That's where the EPA comes in. They cover the public. And process safety management, by the way, is one of the few standards that is word for word identical in OSHA and EPA, except OSHA starts off with the employer shall, because OSHA covers employees. And the EPA starts off each section with the owner or operator shall, because they're not concerned about that. They're concerned about the public and the environment. It's interesting. But facility means the buildings, containers, or equipment which contain a process. Highly hazardous chemical means a substance possessing toxic, reactive, flammable, or explosive properties, and specified by paragraph A1 of this section, which we already talked about. And here's the part of A1. Okay, that's what we already talked about. So I'm not going to read it all again, but that's where that comes from. Hot work means involving electrical or gas welding, cutting, brazing, or similar flame or spark producing operations. Hot work is a word that's used in a lot of sections in OSHA, but that's what it means. It's just basically welding, cutting, brazing, grinding, even anything that produces sparks. It's hot work. More on hot work later. It's element K of the standard and has its own place in OSHA 1910.252. So you can see OSHA permeates, hot work permeates several different OSHA standards. Normally, unoccupied remote facility means a facility which is operated, maintained, or serviced by employees who visit the facility only periodically to check its operation and to perform necessary operating or maintenance tasks. No employees are permanently stationed at the facility. Facilities meeting this definition are not contiguous with and must be geographically remote from all other buildings, processes, or persons. When OSHA does something like this, makes an exception, they have to be as meticulous as possible about defining it, because what will happen is people will try to start taking the exceptions of it to everything. So they kind of made it pretty clear here. I think they did anyhow. Process means any activity involving a highly hazardous chemical, including any use, storage, manufacturing, handling, or the on-site movement of such chemicals, or combination of these activities. For purposes of this definition, any group of vessels which are interconnected and separate vessels which are located such that a highly hazardous chemical could be involved in a potential release shall be considered a single process. So again, they want to be sure that you didn't just take these things and put them in different tanks and say, oh, we only have 5,000 here, 5,000 here, 5,000 there. We don't have 10,000 at one facility. You know, we had an issue because plant one and Reed Lane at OK Foods combined only had about 7,000 pounds of ammonia, or plant two had like 35,000 pounds. They were both under the same, kind of in the same building. I mean, you could get one to the other without going outside. So we included plant one and plant and Reed Lane in it for a couple of reasons. Number one, they probably were in another and by this definition come under it. Number two, we thought, look, if we don't do it and we have a problem there, and they're going to say, wait a minute, you knew what to do here with this plant. You knew what rules to follow. You didn't follow them over here. How stupid is that? And you're probably going to be in trouble. So replacement in kind means a replacement which satisfies the design specifications. This comes up a good bit in practice, because you have a valve, let's say, or something that needs replaced in your covered process. Okay. Now, the first thing they have a valve that's by company A. They have to have a valve that's by company A. No, you don't. You don't have to have that. It has to be replacement in kind. In other words, it has to have exact same specifications. You know, the input, the output, the capacity of it, the operation of it, exactly the same. It could be a different one. Now, if you do that, replacement in kind, it exempts you from going through some other process, which we'll talk about later. But replacement in kind is an important term in process safety management. Oh, there you go. If it's not a replacement in kind, it triggers such things as management of change and pre-startup safety review, which we'll talk about later. So again, it meets exactly the same specifications. It can't deviate at all. Not at all, except the name can be different. It might be a different color or something like that. It might look a little different, but the specifications have to be the same. Trade secret means any confidential formula, pattern, process, device, information, or compilation of information that is used in an employer's business, and that gives the employer an opportunity to obtain advantage of competitors who do not know or use it. See Appendix E to 1200 definition of trade secrets, which sets out the criteria to be used in evaluating trade secrets. And again, they're pretty strict on this too, because you can't really get out of any OSHA by calling trade secrets. You know, you might have to jump through some hoops, but you're not going to get out of OSHA by saying, well, it's a trade secret. Frequently, facilities use this section to add any other definitions that they may use in their program. So what we did, and I suggest you do this too, is for every section, like this is C, for example, we broke our process safety manual into sections, one for each section of the standard, which makes a lot of sense. And the beginning of each section, we put word for word the standard, and that was in italics, so you can tell a little differently. And because they're not that big, as you can see. So we had the standard right there in our standard, and then we wrote below that our policy to enforce that standard. And I thought it was a pretty good way of doing it, and Craig taught us that too. So employee participation. OSHA likes people to be notified of what's going on around them. And you know what? Companies should too. Employers shall develop a written plan of action regarding the implementation of the employee participation required by this paragraph. Again, it's got to be in writing. So they got to say, oh, what are you going to do? That written plan, that's key is that it's written. You can't just be doing it. You have to have a written plan to do it. For example, it's okay if we do this during orientation. We gave them a handout. They signed maybe a short quiz about it. We told them about it. We told them we have it, anhydrous ammonia. It's not a secret. You can't keep stuff like this secret from your people. Short quiz they might pass. We gave them an orientation quiz. It was pretty short. Anyhow, PSM posting, we did that. We'll cover that in a little bit. Annual refresher training for people, more for those actually engaged in it, such as minutes of PSM committee meetings. So you have different levels of this for participation. The average employee doesn't need a lot. You have to know what it is. They have it, what it is, what can do to you, that type of thing, where they can find more information about it. So all employees can't be involved in all aspects of process safety management, but they are varying degrees. But people that are at a plant who could be exposed to if there's a leak, they have to know what it is. They have to know what to do if there's a release. How do you know it's a release? And one nice thing about anhydrous ammonia is it's self-alarming. It stinks. In other words, and because the fact that you'll know it way before it gets to a threshold level that's serious. I'll talk about that later. This is a posting that's in OSHA, and we posted this on every bulletin board. It lists all the different things of process safety management, lets people know about it, and whether they read it or not, I don't know, but it was there for them. That's what we did. I think it's a good idea. Employers shall consult with employees and their representatives on the conduct and development of process hazard analyses and on the development of the other elements of process safety management and this standard. Process hazard analysis, we'll talk about that in the next module. So consult with their employees and their representatives, and that usually means unions, and that's fine. Again, I've always stated this, that unions are supposed to be for the people, and the safety department basically is for the people too. You might be paid by the company, and you're trying to save the company money by all means, but by protecting the health and safety of the people, you are saving the company money. So not all employees can be consulted on everything, but those in the area where PSM is critical can. The standard is very comprehensive, so some employees can be consulted on various parts of the standard. Employers shall provide to employees and their representatives access to process hazard analysis and to all information required to be developed under this standard. That doesn't mean you can give it to them, they can look at it. They usually don't. Access doesn't mean they get a copy, but they should at least be able to be informed of what it is, where it's kept, who they need to ask to see it. Just like any other standard, the first thing the inspector will do is ask to see the written plan. No doubt about it. Just about everything standard. All right. Now, D, process safety information. Again, this is important too. Process safety information. In accordance with the schedule set forth in E1, which we haven't covered yet, of this section, the employer shall complete a compilation of written process safety information before conducting any process hazard analysis required by the standard. The compilation of written process safety information is to enable the employer and the employees involved in operating the process to identify and understand the hazards posed by those processes involving highly hazardous chemicals. This process safety information shall include information pertaining to the hazards of the highly hazardous chemicals used or produced by the process, information pertaining to the technology of the process, and information pertaining to the equipment in the process. So process safety information in this paragraph D will be used by the chemicals and the hazards of the chemicals, information pertaining to the technology of the process, and the equipment in the process. So there are three main requirements of the element. There we go. The hazards of the highly hazardous chemicals in a process, the technology of the process, and the equipment in a process. Information to the hazards of the highly hazardous chemicals in the process. This information shall consist of at least the following: toxicity information, permissible exposure limits, physical data, reactivity data, corrosivity data, thermal and chemical stability data, and hazardous effects of inadvertent mixing of different materials that could foreseeably occur. Note, safety data sheets meeting the requirements of 29 CFR 1910.1200G may be used to comply with this requirement to the extent they contain the information required by this paragraph. And that's basically what you're doing for the hazards of the chemical. I think everybody would do this, just use a safety data sheet. You don't have to, but that's a good idea. It's allowed. Information pertaining to the technology of the process shall include at least the following: a block flow diagram or simplified process flow diagram. See Appendix B to this section. We'll look at them real quickly here. So a block flow, the flow chart type of thing. Process chemistry, maximum intended inventory. Some of these definitions are what it's an intended inventory. If you have a 10,000 gallon, 100,000 gallon tank, let's say, the rule of thumb is you never fill more than 80% because you're going to have expansion, heat, and stuff like that. But what's the maximum? Do you take 100,000 as your maximum inventory, or 80,000 as your maximum intended inventory? Or do you only plan to keep 60,000 in it? But that's the maximum intended inventory. It's not a very clear thing. This is a block flow diagram. It's not of a real thing, but just shows you different things, how the process goes. Like I said, it's kind of like a flow chart. And this is and the next one is a process flow diagram. So it either requires a block flow or process flow, but not both. So this is pretty bad. Anybody in your refrigeration department could lay this out, or works in that department, whatever it is, could lay something like this out for you. And that's to give people that work in it an idea of how this thing works. It makes a lot of sense. Safe upper and lower limits for such items as temperatures, pressures, flows, or compositions. So in your process safety information, you need to say, okay, we have this compressor, and it has safe upper and lower limits, safe temperatures, pressures, all that stuff in there. This is where your people are going to go to find out how to keep an eye on this stuff, and how somewhat to be sure it doesn't get out of spec. So where would safer and upper and lower limits for a piece of equipment come from? Oops, I thought I had my answer there. Where do you think you'd get that? The manufacturer's information. Every time you buy something as sophisticated as an air compressor or something like that, you're going to get the manufacturer's instructions, manufacturer's information. They are critical. You keep them. They are your basis for building this on that, building this information, process safety information. They're going to tell you all this stuff about it. You need to keep that. I don't know if you do it at home, but when you get something at home, you should keep the manufacturer's instructions too. Now, an evaluation of the consequences of deviations, including those affecting the safety and health of employees. Consequences of deviation shows up in process safety management a little bit. What does that mean? What's a deviation? Well, deviation means you're outside of the range that's acceptable, right? You're deviating from a safe range, whether that's, let's say, the PSI of a tank. So what happens if there's a deviation, the consequences of that deviation? Now, what it means is what happens if something goes out of whack, out of spec, out of tolerance. That's the consequences of it. It could blow up, for example. It could blow up, or could release through a pressure relief valve. Where the original technical information no longer exists. Okay, now this happens in real life, so give them credit for OSHA for doing this. Now, the longer we go, of course, the less this is going to happen. But you might have a piece of equipment that outdates this standard. Very possible. So such information, so when the original technical information no longer exists, maybe the company's out of business. Who knows? You got this thing, you've been using it, works fine, everything's fine with it, but you don't have the manufacturer's instructions anymore, and your manufacturer's kaput. So such information may develop in conjunction with the process hazard analysis in sufficient detail to support the analysis. So you still have to do this, have information on it, but you might be able to develop it on your own. So just because you don't have the original information is not an excuse to not have decent process safety information. The other alternative you have, get rid of it, get another one. So they're not going to let you off the hook. Well, I'm sorry, this company's out of business, so we don't have it. Too bad. You're not off the hook with process safety information. Again, if there is an out like that, people would take it. And then what good would the standard be? Information pertaining to the equipment in the process. This is a big part of it. Information pertaining to the equipment in the process shall include the materials of construction, piping and instrument diagrams, P&IDs. We'll talk about them like this. This is the piping instrument diagram. These were huge at OK Foods. They were hanging on a wall. Sometimes they were in charts, hanging on like flip charts. They would go through them. They could be huge. But a P&ID, piping and instrument diagram. Relief system design and design basis. So relief system design and design basis. The relief system is the pressure relief system. The low electrical classification, skip that, has to be in there too. So a relief system, all pressure vessels have a pressure relief valve. Well, for something like a small one, like a air compressor, that's air in it, if it releases just air, right? But if a tank full of highly hazardous chemical releases, you don't want it releasing into the plant. You want it releasing outside. Generally speaking, it has to release 15 feet above the floor working surface, or the highest people can be. And that makes a lot of sense. So you have to have the design and the basis for the design of your relief system. Most relief systems, pressure relief systems, go, from, like, you may have 3 tanks. They don't all go up the outside. They go to together somewhere, and that goes outside. And that's fine as long as it's in design properly. So that's what you have to have in your process safety information. Ventilation system design. You have, most times, highly hazardous chemicals give off nasty stuff, nasty fumes or gases. So you have to have a ventilation system. You might also have a ventilation system that comes on when you have an emergency, automatically comes on when it gets so many parts per million of this. Your ventilation comes on, your louvers or in your door, in your some windows or doors open, or walls even open up to get air out of there and get that stuff out of your building. So design codes and the standards employed for the material and energy balances for processes built after May 26, 1922, and safety systems, interlocks, detection or suppression systems. That's very important. You're going to have a lot of safety systems. We have ammonia alarms went off. It usually at 25 parts per million was a warning, and 50 parts per million start kicking in and stuff. Or suppression systems. Remember, these could have different chemicals, not just anhydrous ammonia. So you might have a suppression system. You might have, let's say, a water system that comes down and takes the stuff out of here. The employer shall document that equipment complies with recognized and generally accepted good engineering practices. You've heard that term before. It's called RAGAGEP, recognized and generally accepted good engineering practices. So that's another one of those things that OSHA uses, kind of like the general duty clause, that you can't get out of by using any other excuse. If you don't have the manual, or the stuff's old, or all that, whatever, doesn't matter. You still have to comply with recognized and generally accepted good engineering practices. For existing equipment designed and constructed in accordance with codes, standards, or practices that are no longer in general use, the employer shall determine and document that the equipment is designed, maintained, inspected, tested, and operating in a safe manner. Again, you can't get out of it by saying these standards are no longer in use, or whatever, or construction standards of this are no longer in use. You still have to document that it's designed, maintained, inspected, tested, and operating in a safe manner. Recognized and generally accepted good engineering practices, commonly known as RAGAGEP. And you've heard that before in this course, I believe. So that's the first 4 sections, paragraphs you can call them A, B, C, and D, of process safety management. We're going to cover this in like 3 different modules. 3 different videos, so you don't have to look at my ugly face for too much at one period of time. In the meantime, be safe.